Okay, great. So I'll begin this afternoon's session with a brief introduction. Welcome everyone to the IEA Bioenergy Webinar series hosted by the Canadian Institute of Forestry. My name is Natasha Machado and I will be kicking off today's session. Today is Wednesday, July 3rd, 2019, and we're very pleased to have Johannes Lindofer, Francisca Hatzer, and Michael Mandel, who will present on technical, economic, and environmental assessment of biorefineries, developing a practical approach for characterization. Start things off, Johannes Lindofer is working for more than 10 years on international and national research projects in the field of ecological and economic process analysis of emerging technologies, especially in the field of biomass conversion. Currently, Mr. Lindofer is working as a research project manager for the Energy Institute at the Johannes Kepler University in Linz, Austria. He has a background in biotechnology and environmental engineering from University of Applied Sciences in Upper Austria and chemical process engineering from Graz University of Technology. Our next speaker is Francisca Hatzer, a team leader of the Team Market Analysis and Innovation Research of the Kopentenzentrum Holz GmbH and has 5 years working experience in the field of LCA with a focus on bio-based product systems in the R&D phase, as well as on methodological options of sustainability assessments of bio-based raw materials. She obtained her doctoral degree in the field of sustainability research, focusing on the environmental and socioeconomic assessment of wood-based product systems throughout the value chain. She has a background in the assessment of natural environments, such as the habitat quality and forest stand productivity after natural disasters. And the moderator for today's session is Michael Mandel, who is the Managing Director of TBW Research and a highly experienced senior researcher in the field of biorefinery. His main interest is in the developing the biorefinery concepts and technologies for various feedstocks, including grass, algae, agricultural waste, and side products from food and dairy processing. He has a track record in applied R&D for more than 20 years, built on his original university background in environmental engineering. Michael has been active within IEA Bioenergy Task 42 for many years, currently as Assistant Task Leader. And with that, I will now pass it on to Michael to begin today's session.
Yes, thank you very much for this nice welcome. It's a pleasure for me to be a moderator for today's session and give you a short introduction and do a final wrap-up, basically, of today's webinar. Well, we are working, as already introduced by Natasha, in the Task 42 of the IEA Bioenergy. And the Task 42 is has been specifically established to facilitate the deployment of biorefineries for the market, to help new technologies enter the market, to actually show how the systems could work and how the policy and also industrial decision makers could interfere into this process. To put in one sentence, we would like to make the idea of biorefinery work to fly in the future and be a very important part of our economy. So within this field, of course, which is very complex, the analysis and the assessment of biorefineries, of the products, of the value chains, of the technology is very important. And that's today's topic. Well, biorefinery is basically the set of technologies you have to process biomass into a set of different products: food and feed, energy, chemicals, fuels and energy, a lot of products, basically what we are using today. And if you look at the picture showing this light beam, that's a picture I specifically like very much, because that's exactly what biorefinery is doing. Try to create a full spectrum of different products. You can envisage that this employs a lot of different technologies. In upstream and also downstream processes. And if you would envisage this biomass as a trunk, then all those products would then be different branches at that tree, and you would like to cover as many as possible products as your value-added product. Well, why is an assessment needed? Biorefinery is acknowledged as a promising route to deliver those products and energy in a very sustainable way. But today, there's still a quite limited data set available, which is validated for biorefinery environmental performances. And I think we really need to prove that our approach is fulfilling our claim. So by doing so, we would really like to create best practice models, and we would like to generate data which actually can support the claim of being a more sustainable way of processing. And by doing so, we also can really encourage the implementation of biorefinery on a much larger extent. At this session, I would like to give the floor to Francisca, and she will now guide you a little bit through the different classification systems and how we have been developing a methodology and toolbox to do the assessment.
As we have heard right now from Michael, biorefining or its definition starts with sustainable processing. So the definition given implies that we have a need for sustainability assessments, which is about depicting the technological feasibility, but also depicting the potential environmental impact of our biorefinery activity, and also evaluating the economic viability. So in this complex field of technology, this is not a straightforward task because we are often talking about new technologies, new biorefinery concepts, new stakeholders maybe even. So the information we have to compile such assessments is often very much limited due to low technology readiness levels, but also due to confidentiality, for example. So we had to find a starting point at some point, and we decided to start with the technology mapping. So here you see the biorefining classification system, and this is actually where we then started off. But just to inform you, this biorefining classification system was developed within the task 42 in former years, and it was then taken up by the German Engineers Association. So in the background, you see different biorefining classification systems. So a lot of people have tried to approach the complex issue of mapping the possible process pathways from different input feedstocks over platform chemicals, intermediate products, final products, and the different technologies. You see here connected by different arrows. So another sketch is shown in the next slide where you see highlighting the feedstocks, the conversion routes, and the output. So the next slide shows another approach. So you see that the approach to mapping those pathways can be done starting from different perspectives and addressing different levels of detail. So for our task, we wanted to build on the biorefining classification system shown here. And it was our aim to build on a common language. So the players active in the biorefining communities often have very different backgrounds. And as you can imagine, us trying to compile sustainability assessment, often from the perspective of economics or social sciences, we are working in a transdisciplinary field. So the classification system actually starts with mapping the raw materials, and then describes the processes and the platform and the outputs. So here you can see the whole mapping of the biorefinery classification system so far, which was developed within the Task 42, as mentioned before. And this map actually is open to extension. So we hope that we can extend the system as we or you develop further conversion routes. And our task then is to start off here and try to quantify those inputs and outputs and the resource flows in between with economic and environmental data, so to say. So the objective of the technical, economic, environmental assessment is to underpin the sustainability claim of integrated biorefineries, and we try to do so by developing quantitative environmental and economic assessment approaches, by building on generic models which are fed by published data, and those models are then ready to be refined iteratively. So we try to provide this initial model, and then we try to encourage the stakeholders along the biorefinery value chain to support us with the iterative refinement for the technology evaluation. So this clearly follows an open access approach. With this, Johannes will introduce you to the methodology.
Well, hello, I'm going to hop in here. So basically an assessment approach, strongly referring to the German body standard 6310, was basically refined to provide a standardized basis for this characterization of biorefineries in terms of technical, environmental, and economic aspects, and as future work, also potentially social criteria. As you see here, part E basically represents a qualitative characterization of the biorefinery pathway, where a short description, a basic flowchart, and key case study characteristics, like which system boundaries are applied, etc. Then basically part B deals with the quantitative sustainability assessment of the value chain based on a very basic environmental and economic indicators portfolio. Well, as finally a comparison of the biorefinery systems is targeted compared to predominantly fossil-based reference product systems. In the very end, the results are summarized in a tabulated form and graphically presented, resulting in so-called fact sheets for dissemination to a broader public. Then part C includes basically a Microsoft Excel-based template and the methodological framework documented in an activity report. As Michael and Francisco already did highlighted, the assessment is basically available to all involved or interested participants with, let's say, various levels of expertise to cover a large and diversified public and enable a broad dissemination of those results. And also the character of this assessment basically provides the potential for adapting the given pathways. Well, it is therefore possible to integrate other data on, let's say, for example, feedstock input, conversion efficiencies, economic values, and so on, and then by that create new case-specific assessments. However, I would say it is worth noting that the approach does not include optimization approaches or a detailed modeling or process modeling. So in the next 4 slides, the focus is on this practical implementation, on the practical implementation of this approach Well, whereas the selection of the balancing scope in the part A of the assessment has a significant influence on the result of the value-based biorefinery. And basically we start with this polyhierarchical classification, which has been also documented in the VRI standard 6310, and its formal vocabulary is implemented and it's basically operationalized in a flowchart. For a practical implementation, we basically propose to list all the relevant incoming material streams, like raw materials, all processes involved, all input and outgoing material streams, specify the resulting platforms, and prepare the associated qualitative diagram. In the next step, the system boundaries are defined. In general, the methodological choices and assumptions, like the choice of a functional unit or system boundary, the dealing with the multi-product systems reallocation, and so on, or also whether the life cycle assessment that you're doing is accounting for consequential or basically accounting as an accounting procedure, are definitely key issues that really heavily influence the results of the assessment. And many standards and guidelines are available which may be relevant in the context of biorefineries, whereas this approach that we have been chosen is following the existing standards and guidelines. So we're not developing really something new, but yeah, we cannot definitely also go into more details on these issues here. Using quality criteria like the technology readiness level helps to determine whether and to what extent the biorefinery can be competitive to conventional fossil-based processing and product portfolios, as many biorefinery concepts are still under development. As a consequence, well, the present data availability for a qualitative, scientifically sound and understandable characterization of all the various technical, economic, and ecological aspects is definitely limited, especially for the technologies at below technology readiness level. So it's quite important to define for us which technology readiness level are we at the moment. So I'm clicking through those. So in part B, I would like to highlight that the relevant economic and environmental values are generated via we call it a data mining process. Based on, let's say, input and output balances for representative technologies, the indicators for greenhouse gas emissions, cumulative energy demand, and economic values like net present value, operating result, specific product costs are generated. For the present case studies, this is basically performed on published data, but parameter estimations in a more, let's say, aggregated form can also be used to express an initial economic and environmental characterization of a biorefinery concept. So, for example, based on values from laboratory or pilot studies or let's say, internal company calculations. But all significant material and energy streams are required to make such determinations. And then in the concluded environmental assessment, the focus is on greenhouse gas emissions and cumulative energy demand as key indicators. Basically, other environmental indicators and categories such as eutrophication, acidification, or ozone depletion potential are currently excluded from our assessment. Well, especially due to the high variety of the characterization models and the lack of international harmonization on that field. This is, I would say, an outlook. And as I mentioned already, economic evaluation is one important criteria for evaluating the quality of a biorefinery assessment system, especially related to its broader implementation potential. And besides, let's say, the or the best practice net present value method, we can also consider other potential options like calculating specific cost of the product portfolio and then relating those to the total annual cost of operation. And another option is like to simply calculate all costs and revenues compared based on the yearly operations. So then you have some sort of a snapshot of the economic situation for 1 year of the assessed biorefinery system. One aspect that is related to the results part of our assessment is that uncertainties, or we are trying to address uncertainties via sensitivity or scenario analysis in order especially to determine result dependencies on relevant parameters. This is basically done because the applied generic values hardly represent the high variety of the process specific conditions that we definitely might have. And after this process, having all the primary data compiled, key characteristics of the technical, economic, and environmental information are assembled in an illustrative style in the results part, and an overview summarizes the aggregated gas and energy balance as well as the greenhouse gas balance and case-specific cost and revenue structures of the case study that we are looking at. Part B of the results communication is covering the classification, the environmental indicators such as greenhouse gas emissions, cumulative energy demand, and cost versus revenue structures for the assessed case in more detail in order to provide a bit more insight concerning the main drivers. For an improved evaluation of the presented results, it can be stated that the conducted case studies are intending to inform a broader public about the potential benefits and the support in, for example, decision making for further improvements in the technologies, but however, the results based on generic data are not suitable for let's say, business case development, or likewise without case-specific adaptation and review of the considered input data, I would say. So early assessments on pathways for primarily providing biofuels and valorizing side products thereof are available at the task webpage and document previous work in this field. So please be also encouraged to have a look at it. Recently, we have been looking at another 4 pathways concerning the valorization of, for example, lignin in the pulping sector, on the 2nd generation bioethanol production, and 2 pathways for bioplastics and energy provision, which are documented in a forthcoming report. And the next session of our slides present an extract from this work covering 2 case studies in this list. Well, please note that the results demonstrated in the slides and the related report and fact sheets are snapshots of each techno-economic and ecological assessment. That's a meaning that the case studies cannot cover all realization options, and any change in the assessment results in a different outcome and output. So part A of the biorefinery plant that we've been looking at, this lignocellulosic biorefinery plant, incorporates basically all the key characteristics of the biorefinery, including a short description on the mass and energy balance, information about cost and revenues, and this kind of classification scheme that we are stressing in order to really present what are the key process steps within the biorefinery process. So in this case, the primary refining consists of a mechanical pretreatment step as well as a physical chemical pulping of the lignocellulose, followed by a fractionation step. Secondary refining contains further processing steps for the raw products of cellulose, hemicellulose, and lignin. And the assessment covers the production of pulpwood from spruce and pine, the kraft lignin process, and the lignoboost process. So, and it is assumed that all processes take place in Europe. The system boundaries in that field are set cradle to gate, starting at, let's say, forest operation, including planting, thinning, harvesting, and so on, and the pulping process and the lignin extraction via the lignoboost process. So coming to the part A of this refinery case, which incorporates basically the key characteristics on the biorefinery, so the mass and energy balances up on the left-hand side, the information about cost and revenue structures on the bottom. Concerning the part B, the value chain assessment, which this includes basically the information on the system boundary and also the reference system, so the fossil-based comparable system. And as shown in various studies, lignin could be an interesting alternative to current fossil-based adhesives, especially as a replacement for phenol and phenol formaldehyde resins, which has been looked at here and is incorporated in the assessment. So the figures here are illustrating the cumulative energy demand of the case study, the greenhouse gas emission, and cost and revenues. Well, in a comparison with the reference system, under the given assumption of this case study, the cumulative fossil energy demand and the greenhouse gas emissions are lower for the biorefinery systems compared to the reference systems, and well, that's quite clear for such a biorefinery option, and this is practically implemented widespread in the industry. And I would also like to highlight that the assessment of cost and revenues is highly challenged by the limited data availability. But under the given assumptions, the revenues are mainly determined by the pulp, which is understandable to the differences in quantities in the uncertainties of the actual lignin price. I will still stress one case study, which is characterizing a lignocellulosic biorefinery, applying the residue corn stover to produce ethanol as fossil fuel substitute. It has an on-site process steam generation integrated via lignin combustion in a boiler and electricity production with steam from this combustor. Additionally, biogas is generated on-site by anaerobic digestion of the wastewater, and so no external energy supply is needed. Depending on the operation mode, excess electricity can also be generated. And the case study is literature-based, but I would say highly relevant if we consider the international promotion of biofuels from residues. And the mass balance for the considered pathway illustrates basically the feedstock intensity. It's the lighter blue bar of the lignocellulosic biorefinery, and various pretreatment processes are applied in the field on the feedstock. But typical for all biochemical conversion pathways is the high water turnover in these processes, which deserves always special attention and an optimal design, we would conclude. Well, based on the feedstock, the proportion of lignin varies, and its illustration is a key aspect influencing the environmental performance of the value chain, which is basically represented also via this sensitivity analysis on the bottom. So when in terms of the value chain assessment of this case study, I can say, well, the environmental impacts of second-generation ethanol biofuel production are well examined in literature. In Europe, especially, the methodology in the Renewable Energy Directive is quite prominent and commonly applied. But the comparison to, for example, the Renewable Fuel Standard program in the US, or the Clean Fuel Standard Regulatory Design in Canada, is potentially also possible. The systems are analyzed based on the functional unit of the terajoule fuel produced. And if we look at the results here as well, well, if the raw material corn stover is defined as an agricultural byproduct with no allocation of greenhouse gas emissions from major agricultural operations, then the biorefinery operations provide the strongest impact on the results. And if additionally credits for excess electricity are applied in other product systems, greenhouse gas emissions from biorefinery options can be compensated, even though, and the carbon footprint of the product system strongly decreases. And this, I would conclude, is also the strong advantage of implementing a biorefinery approach, which comes into effect here. So with that, really, let's say, try to be rather comprehensive on the specific case studies, which also can be read in the forthcoming activity report on that, and also on the web page of the Bioenergy Task 42. I would like to give the floor back to Francisca.
So having seen the case examples we compiled during the last years, we are quite excited about the advancement of our biorefinery classification or assessment scheme. So we expect that our sustainability assessment progress with the further development of the technologies and also the market penetration. With a modular approach of our assessment, we have the possibility to adopt to those developments. So we can generate new assessments within our data collection. Further, we hope that we can advance from our case study perspective to a more generalized perspective. So we hope that we can achieve sort of a standardized characterization of the different biorefinery concepts. So speaking of technology, economic aspects, and also environmental aspects. So we have been talking about the data limitations very much, because data is the basis of our assessment. So we have the aim to collect the data for the analysis in order to compile the characterization. Apparently, without data, we cannot achieve this. So, as mentioned before, we have restrictions in data availability due to the low TRL levels of the technologies, and also due to confidentiality reasons. We have also experienced that stakeholder participation is restricted, also due to confidentiality, but also due to conflicting interests. So especially at low TRL levels, we have experienced that researchers, but also industry, is quite quiet about talking about their new technology and so on. So we now have predominantly totally aggregated and highly case-specific results. So the data we find published in scientific literature databases, for example, very much describe case studies, and the data found there, the inventory data, is highly aggregated. So the analytical approach we can take is quite limited due to that. Of course, we hope that our situation will improve. So the outlook for us is that we still feel motivated to expand our assessments and to integrate the new concepts and process pathways, because we believe that biorefinery concepts are an important building block for establishing a sustainable bioeconomy, and thereby also sharing data plays an important role, especially if we think about the open science paradigm of the European Union. We feel hope to improve our data situation. So for the next step, we want to have our data and our assessments reviewed by experts, both from academia and from industry. We also want to incorporate new R&D results and implement experiences also. So the integrated data quality assessment for the interpretation is very, very important. And at this point, it's also necessary to have feedback rounds with experts from the field. So together, we hope that we can achieve the iterative refinement of our assessment, and we very much seek an open access approach as mentioned before, and therefore we also try to engage in a collaborative intertask project in order to support our efforts. So with this, I would like to hand over to Michael.
I would like to use the last slides of this presentation to really make an outreach to all of you participating today in this webinar. I think there is also a chance for cooperation really, and what we really would like to do, we want to get more involved, deeply involved with industry to collect better data sets to do this assessment. And I think it's really necessary to get data and describing information from biorefineries which are in operation and also at higher technology readiness levels such as demo and pilots. And this could be also a chance for industrial players to get involved, because we would be delivering some results which are available then even for assessing their own processes. And if you have a good process and you know yourself about it, and the results and this knowledge is basically locked in your drawer, it doesn't help you also to do promotion of your technology. So I think that could be really also a benefit for enterprises. The idea is really to extend the data sets on relevant results and best practice models. And because of the good network and dissemination action IEA Bioenergy can actually offer, this is something I think which can also be used more efficiently by industries if they would like to get technology performance communicated on a larger extent. So this is what we can actually offer, and hope that there are some enterprises which are interested maybe for cooperation. So we could do the assessment work for you, but you still would need to get involved to do some data collection and provide the data. There can be a confidentiality agreement be established. That's not a problem. We can aggregate the results so that no direct conclusion can be made about the detailed process. All of that is possible. Please, if you find that idea attractive, just contact us. We would really like to get involved more in operational biorefineries. So for me, it's really about to thank you for your participation today. You find our contact details on the last slide, and I think now it's really about to get more deeply about your ideas, about your questions, to merge our webinar to be more interactive, get your opinions and questions incorporated into here. So I would kindly ask Natasha yet to open for us the chat option. So I would like to highly encourage you to put forward your questions. And the way the procedure we will be doing this is you can type it in, so we can actually get it on our whiteboard, and then make the collection here, and just go through the questions after each other. So first come, first serve, so to say. And I would also like to invite you to do a little bit of our polling there. So we would like to invite you to fill in this small chart here. We would like to get information about your background. So we're still waiting for the first questions to come up. So far we haven't got any questions yet. So the topic is still confusing, and some of you might be still confused at a higher level, but this is the chance maybe to get more precise information for you. Questions that takes a long time to type in. Maybe I bridge the situation by the announcement of course, that all the slides will be available after this webinar, of course. There will be free download for those slides from the Task 42 webpage. And I would also like to announce that a much more detailed report on this technical, economical, and environmental assessment has been prepared and will be launched tomorrow from Task 42's webpage. So it's there for you for the free download, and you find much more information, more detailed description on the methods applied and the results delivered.
Hello, Johannes speaking. May I also answer some of the questions? I think the first ones have been already answered by Michael in terms that the assessments and the, let's say, framework report on that will be published on the web page within this week. And the last question, what is the difference between this approach and an LCA approach, is basically that this is a more, let's say, also including a bit in more detail the technical aspects or the technical characterization via this standardized, let's say, framework of defining the process flowchart, and especially also because of integrating economic indicators. So the life cycle assessment approach is normally just referring to environmental indicators. So we basically focus on the main environmental indicators, but also on economic data to cover a broader range of sustainability indicators.
I would like maybe to go into the questions dealing with the Excel sheets. The methodology which has been explained during the webinar is basically programmed in an Excel sheet, which is a straight, because it is widely used and commonly applied piece of software, so it's not a specific expertise, a specific software in the background. This toolbox has been generated by the task. What we can offer is to put the task in those templates to do an assessment for industrial partner, and also can apply this specific sheet maybe for PhD students which would like to do assessment on the new concept of technology. This is important. However, the Excel sheets are quite complex, it would need a little bit of assistance of getting the right results out of the system. So we will be providing the sheet as a free download. So if you really want to use templates, you will need to contact us directly, and we can then agree on how the data or the tool can be used. Maybe Johannes, you could maybe answer the question on the difference between the TE approach and the LCA approach. What could be highlighted as the main differences?
I basically did it already. You couldn't hear us, or you couldn't hear me. I don't know.
Yeah, maybe that. Sorry about that. Yeah.
Maybe I can repeat it. So the difference basically is that that our assessment is covering also economic indicators. So not just environmental indicators like commonly applied within LCA methodologies. So this is a certain extension and towards more sustainability indicators. The other question that is raised here in order to basically identify best practice options for using the limited biomass feedstocks that are available. Well, this is a very good, very perfect idea, and it's definitely challenging. What I would say, what potentially this kind of method and toolbox could do in the future is that it kind of is broadened to a broader technology setup that is represented in this toolbox, and then it needs to be put on a dynamic dimension. Otherwise, at the current state, it's still static. So, and then it probably can assist in answering these questions in order by comparing different biorefinery options, not kind of focusing at the moment on comparison with fossil reference systems. Concerning upscaling data compared to laboratory data, I would personally say this method and approach could be quite valuable for this, especially for kind of starting with laboratory data, because it's easy to fill. It is not that complex. It basically relates on a simple mass and energy balance. You do not need to extensively do simulations, process simulations, or upscaling procedures. And then it would be always definitely of interest what is then in the next TRL level happening, and how are the input data, but especially also the results are differing from the two assessments. This is definitely an applicable potential case for this method.
Yes, I would like to add that the evaluation, although it is static, very much helps to understand the technologies and their environmental and economic characteristics. So the approach is definitely iterative, so you can start collecting the data and implementing it in the sheets, in the assessments already at early TRL levels, and then update the sheets so as you gain more information. And then you definitely can see hotspots or how certain decisions in the process line influence the assessment results. So in comparison to the iBioRef software, our approach is rather simple, so to say. The iBioRef software, for those who do not know, is a very sophisticated simulation model which was developed in Canada. So that software is not open access. So we on purpose tried to go for building knowledge within the community on basis of sharing knowledge, open access, and trying to advance to go beyond commercializing the data we have so far. So we really try to encourage the knowledge transfer between the different players. So let me also answer the question considering the lignin. Where was the question? So we've published a paper in the journal Sustainability, which deals with identifying sustainability levers through hotspotting lignin valorization pathways. So you might be interested in that publication. It's also open access.
I would like maybe add, which we have unfortunately forgotten to announce, that all those presented biorefineries are available as a fact sheet, as a 4-page fact sheet very soon from the Task 42 webpage. And in addition to the presentation of those results, there will be an annex. And this annex actually gives you more insight about the original data, how it was accumulated, and you can also have some interim results in these annexes, so that means that it helps to understand maybe how half of the process performs. And for us, this information is also very valuable because this will be the basis for future updating. So the data sets are there in the background, and I think this is also a very good contribution to potentially stimulate the discussion on LCA on a broader extent. There's one question about comparing different biorefineries, and as I understand the question, not to compare it with a petrol refinery, but comparing different biorefineries between them. I think that it is possible. We have not been doing this so far. We need to bear in mind that whatever biorefinery you are collecting the data with is that you always get an array of products, and then it will be very difficult to compare different sets of technologies delivering different product portfolios. So I don't have a straightforward answer for you for that. Maybe Johannes can add to that.
Yes. Well, basically, I agree with what Michael said, and you can compare definitely also biorefineries producing non-petroleum-based products, but as Michael said, you need to be on the same level in terms of providing the same products, or at least the same service capacity of the product. That is quite relevant. Otherwise, you're always comparing let's say, apple with pears, and that needs to be avoided. But basically, the systematic is as open as this to do this.
I see that there is some side discussions going on the lignin biorefineries. I highly welcome you to do so. So if you can make new friends and contacts, please do so. At this point, I would also like to remind you that it's always worthwhile to check out that 42 webpage, because what we really want to do is bring new reports, new results on the table for dissemination. So it's a good hub for results or specific reports. Maybe just looking backwards, there was a new report published some months ago on fibers and fiber material products. If you're interested in that, just check out the webpage on this. May I ask you, whoever is typing, that you need to mute your microphone, otherwise we will witness this. I would also like to add that besides of the data which has been presented in this webinar, there is also a set of previously executed biorefinery assessment which is available via the web page. You have seen those 9 cases in one of the slides. If you go through the web page, you will find the data of the assessments and fact sheets for those biorefineries as well.
Maybe I can ask on the question that has not been really addressed concerning scale of the process. Sorry that we kind of potentially oversaw this question. So for the time being, we basically try to choose representative scales of the process. This is then also related to the technology readiness level that is already available for a certain process, and then kind of present representative data for this scale, and also to kind of potentially include scaling into the sensitivity analysis of the categories on economic and environmental results. But yeah, this is also still a topic that could potentially also be improved in the future, definitely. Yeah. Because for sure not all the systems are really linear to each other, or definitely far away from linear, some of those.
Maybe we should also go to the question Van der Wien has been putting forward, I think, the second time. So he's asking what would be the best way of processing the limited biomass available, and I assume he's asking about technologies and co-products here. This is a very, very difficult question because the technology toolbox for biorefinery is really, really big. So you would need to further characterize the feedstock, so whether you will be doing something for lignocellulose or for sugars, proteins, or secondary compounds. There is no master plan where you actually can say this is the best technology, just copy that and you're fine. So they are all very specific, very customized on specific compounds and feedstock categories. So sorry, I haven't got a better answer for that.
Well, not really. Just a bit to recap. What we are trying to, or we are doing, trying to modularize our assessment in terms of that we have the block of different feedstocks, then the block of different pretreatments, and for example, then further processing steps. But there is definitely still a lot of work to do in order to really bring this to a level of a representative portfolio of those modules in order to be able to combine them in a huge variety, and therefore then give some, let's say, hints on what best to use and what best to apply for certain feedstocks. And this then also potentially could be just done on a rather regional scale. So that is kind of quite an outlook, I would say.
Thank Luke for your announcement again on the coming publication of the slides and the report. So you have two options basically to download this information, which is included in his blog. All the participants, maybe if there are further questions, please come forward and put them in the chat option. If we do not have any new questions or issues to be clarified, I would really like to thank you for your participation in this webinar. I hope you could take some messages, knowledge, and methodology with you. And again, all the information, the slides, and the reports will be available soon. And again, I would like to address our specific wish to build a stronger link to industry and try to kickstart some of the corporations to do also industrial scale assessment of biorefineries. I think that's from our side. I thank you again, and I would like to close the session.
Thank you, Francisca. Thanks, Johannes, and thank you, Michael.
Thank you very much.
Bye, everyone.